Section 3.3, proofs with parallel. Our essential question here, for which of the theorems involving parallel lines and transversals is the converse true? It's asking from the section 3.2, which of those theorems have the converse be true? The simple answer is all of them. Okay, so this lesson seems very similar to 3.2. Basically, the difference is the direction we're going. Instead of knowing the lines are parallel, we're showing that the lines are parallel based on the angles. So, corresponding angles, converse, if two lines are cut by a transversal, so the corresponding angles are congruent. So here we have 2 and 6 are congruent because of the markings. So what we know then is the lines are parallel. Sorry, I spelled wrong. Then alternate interior angles, converse. Right, we have 5 and 4. If two lines are cut by a transversal, so the alternate interior angles are congruent, which they are, then the lines are parallel. Alternate exterior angles, converse. If two lines are cut by a transversal, so the alternate exteriors, 1 and 8, are congruent, then the lines are parallel. And then our consecutive interior angles, converse. Okay, if 3 and 5, if our consecutive interior angles are supplementary, which means they add to 180, then our two lines are parallel. So the consecutive interior angles of supplementary, then the lines are parallel. Okay. So we want the same thing we were looking at before. The difference is we're starting with the angles and showing the lines. So we look at example 1 here. It says find the value of x that makes m parallel to n. So in 3.2, it was saying m is parallel to n. What is x? So we're just going the opposite direction. So setup of problems looks the same. These two things are, those two angles are corresponding angles. So for the lines to be parallel, they have to be congruent. So 71 equals 2x plus 3. So 68 equals 2x. And x is 34. Example 2, find the value of x that makes m parallel to n. Here, these are consecutive interior, so they should add up to 180. So 2x plus x equals 180. 3x equals 180. Divide by 3, x is 60. Then turning the page, example 3 changes up a little bit. It says, can you prove that lines A and B are parallel? Okay. So we're looking at, do they give us the right information to match up? So A is looking at this top part here. They say 1 plus 2 adds up to 180. They're consecutive interior. So this would be yes by consecutive interior angles. B, 1 plus 2 equals 180. But here, I don't have consecutive interior angles. They're alternate interior. So this is no, because alternate interior angles are congruent, or should be congruent. And then C, here we have alternate exterior angles. They're congruent, and so that's yes, alternate exterior angles. So now realize B, we're not saying those lines aren't parallel. We're saying that based on the information, we don't know that they're parallel. Okay. Transitive property of parallel lines. If two lines are parallel to the same line, then they are parallel to each other. Okay, so here it says if P is parallel to Q, Q is parallel to R, then P has to be parallel to R. Right, which makes sense. Right, if I have these two lines that are parallel, I draw a third line parallel to the middle one, it has to be parallel to the top one. And then example 4, okay, is looking at our proof. Okay, and these proofs really aren't that bad if you know your rule. All right, just watch what they're asking for. They say A is parallel to B and 1 is congruent to 3. Okay, I'm trying to prove that X is parallel to Y. So right now, I don't know those two lines are parallel. Okay, so A parallel to B and 1 congruent to 3, that is my given. Okay, now angle 1 is congruent to angle 2. Those are corresponding angles, and those lines are parallel, cut by transversal X. So my reason here is consecutive interior angles. That's not right. Corresponding angles. Why do I have consecutive interior? Corresponding angles. Those are corresponding angles. Bad information. Then 3 says 2 is congruent to 3. Okay, be careful because 2 and 3 are alternate exterior, but I don't know that these lines are parallel. So that can't be my reason here because the lines need to be parallel for me to use that. The reason I know that 2 is congruent to 3 is 1 is congruent to 3 and 1 is congruent to 2. So that is the transitive property. You might technically be able to use substitution there, but transitive is the better property to use. And now I know X is congruent to Y because of the converse of the alternate exterior angles. I'm not going to worry about writing converse. We're just going to say those are alternate exterior angles. Right? But it is the converse, and that's why we're going to parallel lines, so that I've proved that X is parallel to Y. Okay, and that is our notes for 3.3, okay, and the converse of our theorems on parallel lines and the angles they make.